Alright, y'all, today's essential question is how do we determine if a function has symmetry, and then if it does have symmetry, how do we classify it as being even or odd? Now, don't get this confused with like an even number like 2, 4, 6, 8, 10, or an odd number like 1, 3, 5, 7. This has its own very specific and distinct definition. So today's essential question is how do we determine if a function has symmetry, and then whether or not that symmetry is even or odd. So just keep in mind that some functions might not have any symmetry whatsoever. Alright, let's just start off the lesson by reviewing what symmetry is. Now, symmetry is actually everywhere in nature and also in architecture. We love symmetry because it just makes things very neat and pretty. A definition of symmetry, which I borrowed from Wikipedia, is something in which the item or the insect in this case, or hands, or the building, or the drawing, in which something can be divided into two identical halves by either a line or a plane passing through a central point or axis at any angle. So in other words, you have some sort of symmetry. Like, for example, there's symmetry on the Taj Mahal right there, right, either on the left or the right. There's symmetry, like with your hands, symmetry with a butterfly, and even symmetry with this art piece right there. Notice that I drew vertical lines on every single one of these, so you could kind of call that vertical symmetry, right? It's same on the left and the right. But in the case of functions, we like to classify functions as having symmetry of either being even or odd. So let me give you a quick visual definition of what even and odd symmetry looks like. Even symmetry is whenever you have a function that is geometrically symmetric about the y-axis. So in other words, the y-axis is your vertical up and down. So if it splits the function in half down the middle, and it's a mirror image on the left and the right-hand side, then that's symmetric about the y-axis, and then that's even symmetry. Odd is symmetric about the origin. So that's a great way to look at it right there. Basically, from a geometrical standpoint, if you are able to take the function and literally flip it upside down, and it has the exact same shape as before, then that would be an odd symmetry. Alright, so let's take a look at some examples of even symmetry. Alright, so even functions have y-axis symmetry. So for example, if you see the graph on the left in complete blue, you can split this function down the y-axis, and it's the same on the left as it is on the right. It's a mirror image of each other. Same thing with this function here. If I split it right down the y-axis, then it's the same on the left as it is on the right. And there's the y-axis. Alright, now from a numerical standpoint, like a point standpoint, it says, so for an even function, for every point xy that is on the graph, the point negative xy is also on the graph. So like, for example, this point on this function is negative 2, 0. So by that definition, the point positive 2, 0 should also be on that function. And then just like right here, this point is negative 3, positive 5, so the point positive 3, positive 5 better also be on that function. So in other words, if it's an even function, if you have the point xy, then the point negative x, positive y, is also on the graph. Alright, now let's take a look at some examples of odd functions. Alright, odd functions, like we said, have origin symmetry. Now, I unfortunately aren't able to pick up this screen, but if you could just tilt your head completely upside down, you'll notice that with the function on the left, I'll put a little star on it, if you were to literally flip that upside down, you would get the exact same picture as it looks like now. Same thing as the function on the right. So if you look at this function as well, if you were to flip that completely upside down, it would retain its shape. It would be the exact same picture. And so that would be odd symmetry. Let me see if I have a definition. Yep, right here. Alright, so for an odd function, for every point xy on the graph, then the point negative x, negative y is also on the graph. So like, for example, let's say that this point is, let's see, 1, 2, 3. So this point is 3, 1, 2, 2. So then by that definition, the point -3, -2 better also be on the graph. So -1, 2, 3, -1, 2. Sure enough, there's that point right there. So again, from a numerical point basis, for an odd function, if the point xy is on the graph, then the point -x, -y is also on the graph. Now, for all of these examples so far, I've been giving you pictures, and you can typically visually be able to eyeball whether or not a function has symmetry and then whether or not it's even or odd. But let's say I don't give you a picture. Let's say I don't give you a graph. What if I just gave you an algebraic function, or a polynomial function? For example, if I tell you the function f of x equals 5x to the fourth minus 2x squared plus 1, and I want you to classify if this is even or odd, or it might not even have any symmetry whatsoever. Well, here's the basic rule. All you have to do is plug in -x into the function. If you get the exact same thing, I'm going to highlight that, the exact same thing, then it's even. If you get the exact opposite, then it's odd. And then if it doesn't fit in those two categories, then it's neither. But let's just test this out and see what type of symmetry, if it has any, even or odd. So what I'm going to do is I'm literally going to plug in -x into the function. So 5 times -x to the fourth minus 2 times -x squared plus 1. And then -x to the fourth is a positive, so positive times positive 5, so that'll be positive 5x to the fourth. -x squared is positive, positive times a negative, so that'll be -2x squared, and plus 1. Now, you have to look at each term individually. Notice this was a positive 5x to the fourth, this is a positive 5x to the fourth. This is a -2x squared, this is a -2x squared. This is a positive 1, this is a positive 1. They are exactly the same, so therefore, it does have symmetry, and it's an even function. And you could verify that if you wanted to plug the original function into your graphing calculator, and you could look at the graph, you could verify that it is symmetric along the y-axis. Alright, so, again, can't stress that enough. Plug in -x. If your function is exactly the same, it's going to be even. Now, if it's exactly opposite, then that means it is an odd function. So exactly the opposite, then it's an odd function. So let's say I gave you this function, and I wanted you to tell me if this function is odd. Alright, so again, you simply plug in -x, so plug in -x into there, and so I'm going to get 2 times -x to the third minus -x, be careful with the signs. -x to the third is a negative, negative times a positive is a negative, so -2x to the third, and then a negative times negative is a positive x. Now you have to look, it has to be completely the opposite. So look, it's a positive 2x squared, now it's a negative 2x squared. It's a negative x, now it's a positive x. So they are completely opposites, therefore this is an odd function. In other words, it has symmetry, about the origin. It's symmetric about the origin. Okay, alright, now let's take a look at an example of where neither shows up. So let's say that I wanted you to determine if this function was even or odd, or it could be neither. So we're still going to do the same thing. We're still going to plug in -x. So if I plug in -x, -x to the third is a negative, negative times positive is a negative, so this will be -5x to the third minus 1. Now most people are going to say, oh, it's odd because I've got a positive 5x squared and I've got a negative, a positive 5x cubed and a negative 5x cubed. But here's the issue. I've got a -1 and it's still a -1. So they're not exactly the same and they're not exactly opposite, so this case is neither. Alright, let's take a look at one more together. Alright, let's say that I give you this function, and I want you to test whether or not it's even, odd, or neither. So I'm just going to plug in -x, and the -x to the fourth is positive, positive times a negative, so that'll be -3x to the fourth. -x squared is a positive, positive times a negative is a negative, so that'll be -x squared, and the plus 2, nothing happens to that. So I've got a -3x to the fourth, negative 3x to the fourth, negative x squared, positive 2, positive 2. What's your verdict? They're not opposites, and they are exactly the same, so it would be even. All right, here's what I want you to do. Take a minute and try out these guided practice questions. There are 10 of them. If you would, just go ahead and pause the video, because I'm going to go ahead and give you the answers to them as well. So I would go ahead and pause the video now, take a couple minutes, and once you've got your answers, go ahead and hit play again. Alright guys, here are the answers to those 10 questions. So the first one was odd, the second one was even, the third one was odd, the fourth one was even, the fifth one was odd, the sixth one was neither, the seventh one was even, the eighth one was neither, the ninth one was neither, and the 10th one was even. And then guys, that's it. So I hope you enjoyed the lesson, and I hope you learned a little bit about even and odd functions.